I'm Kavita Joshi from Dr. D.Y. Patil Institute of Engineering, Management and Research, Akodi College, from Electronics and Telecommunication Department. My subject is Basic Electronics for the International FDP on Environment and Sustainability. My week 1 video details are related to the solar DC power supply, that heavy CO2 emission is generated by power generation using traditional method. Low CO2 emission is possible with the solar power, hence it is called as a clean energy or green energy. This energy or the electricity can be stored into the battery. My week 2 videos are related to the power supply, PV power supply or related to the PV plant, and all the ISO standards or the international standards have been given into the week 2 content. Video outcomes. Student will understand the solar energy is renewable and zero harmful emissions and sustainable energy. Aware application of solar energy in laboratory. Student will compare carbon emission of conventional electricity with solar energy. Apply the use of solar energy in daily life. Apply solar energy in villages, remote areas for betterment of environment. This is the table for the list of ISO, IEEE and industry standards and norms. I have taken the standards as IEC, ISO and IEEE and the same. IEC standard for the PV is or the solar energy is IEC 61724-1 2017. It is active, published and on March 2017, and technical committee is IEC TC82 worked on the solar photovoltaic energy system. This gives the standard for PV monitoring systems. Second standard is ISO, International Standard for Organization 9806-2017. It is published and publication date is September 2017. Technical committee is ISO TC180. It specifies test methods for assessing the durability, reliability, safety and thermal performance of fluid heating solar collectors. IEEE standard 1562-2007. It is active, published on 5 December 2008. The committee is SASB SCC21, and it gives a method for properly sizing the PV array and battery for standalone PV systems. The fourth standard I have chosen is SEMI PV 231011, which is active, published on March 2018, and the technical committee work for this is Photovoltaic Global Technical Committee. It gives the test methods for mechanical vibration of crystalline silicon photovoltaic modules in shipping environment. This is the graphical structure I have taken from the net. So this is CO2 emission from the several power supplies. We can see that the coal-fired generated electrical supply gives the highest CO2 emission, whereas solar power gives about 38. So all this renewable energy gives the lowest CO2 emissions compared with the traditional one. Now this is the case study paper I have chosen from internet, that reduction in CO2 emission through photovoltaic system, a case study. These are the two members, Saurabh Kumar and Ombir Singh, and they have used the site Varanasi, Uttar Pradesh, India. Now total electrical energy provided to the load for one day is E per day is equal to E into efficiency of charge controller into efficiency of inverter. So efficiency of charge controller and inverter, it has been taken as 0.95. So E per day, means energy per day, will be 5.78 multiplied by this efficiency of charge controller and inverter. So it gives energy per day is 5.22 kilowatt hour. Total electrical energy provided to the load for 1 year is calculated by considering the number of clear days in a year. So for this side, now the author has been considered as 325 clear days, so where you are getting the full sunlight. So E per year is equal to E per day into number of clear days. Now E per day, it has been calculated as 522 kilowatt hour into clear days for this side This may vary per site 325. So E per year is equal to 1695 means 1695.25 kilowatt hour. So the yearly electrical energy output from the PV system is 1695.25 kilowatt hour. Now this is the comparative analysis of CO2 emission in the PV generator with the coal-based plant. So PV system, according to the Tiwari and these are the authors, they have put on these calculations. So if electricity is generated from coal-based plant, on average CO2 equivalent is 0.92 kg of CO2. As there are no transmission and distribution losses in case of PV system, and the lifespan it has been considered as 35 years. So CO2 emission per year is embodied energy into 0.98 into lifetime. So in this you can get the full calculation as 237.8 kg per year. This is the CO2 emission per year for the PV plant. Now we will calculate the CO2 emission per year for the coal-based plant. So average CO2 emission is 0.98 kg of CO2 approximately. In coal-based thermal power plant, losses of transmission and distribution are 40%, whereas these losses, there are no transmission and distribution losses into the PV system. So this also we should have to take into consideration. So for a coal-based power plant, the total CO2 equivalent will be increased, and the intensity for generation of electricity will now become 1.63. So 0.98 it has been increased to 1.68 because of this 40% addition of transmission and distribution losses. So CO2 emission per year is equal to 1.63 into this is the 1.63 into 1695.25, which we have calculated here. 1695.25 kilowatt hour is equal to, we are getting 2763.26 kg per year. Now we'll find out the reduction of CO2 emission. So electrical generation using coal-based plant and the PV system. So 2760, this is the coal-based plant electrical generation minus 237.8. So this is the reduction of CO2 emission per year. It is the 2525.45 kg per year. Since the amount of CO2 emission is possible if we use the solar power instead of the coal-based plant. Thank you. Before that, we go to the sustainability computation and standards. So usual power supply sustainable to last a minimum of 5 years if operated 24/7. After 5 years, the efficiency of power supply will surely degrade. If you operate the power supply at near or full load, the heat generated will be higher than the years before. Now this is the graphical structure, how it goes to the approximately 4.34. The operating time which will device is 100% CTR is around 40,000 hours, which is around 4.354 years. When operating continuously at the maximum temperature of 70 degrees, the power supply life could only be 37,500 hours into 1 day is 24 hours, 1 month is 30 days and 1 year is 12 months. So finally you are getting 4.34 years. So this is the calculation that how this power supply it will be sustainable for 5 years if it will be used